Nomenclature of carbon compounds. Organic compounds generally have two types of names. These are IUPAC and common names or trivial names. The IUPAC names have been adopted by the International Union of Pure and Applied Chemistry and are based on certain rules. The common names, known as trivial names, have no proper system of naming. Organic compounds can be divided into acyclic or open chain compounds and cyclic or closed chain or ring compounds. These can further be divided into homocyclic and heterocyclic compounds. Homocyclic compounds can further be divided into alicyclic and aromatic compounds. Aromatic compounds can be further divided into benzenoid and non-benzenoid compounds. Writing IUPAC names of compounds. According to IUPAC system, the name of the organic compound consists of four parts: prefix, word root, primary suffix, and secondary suffix. Prefix. Prefix is a part of IUPAC name which appears in the beginning. It denotes the substituent group if present in the organic compound. The prefix for a few substituents are shown on screen. Word root denotes the number of carbon atoms in the longest possible chain. For the chain containing up to 4 carbon atoms, special word root, meth for 1 carbon atom, eth for 2 carbon atoms, prop for 3 carbon atoms, and but for 4 carbon atoms are used. For chains containing 5 or more carbon atoms, Greek numbers are used. Word roots for different carbon chains. Chain length C1, word root meth. Chain length C2, word root eth. Chain length C3, word root prop. Chain length C4, word root but. Chain length C5, word root pent. Chain length C6, word root hex. Chain length C7, word root hept. Chain length C8, word root oct. Chain length C9, word root non. Chain length C10, word root dec. In general, the word root for any carbon chain is alk. Suffix can be of two types: primary suffix and secondary suffix. Primary suffix. The suffix which is used to represent the saturation or unsaturation of carbon atoms present in the parent chain is called a primary suffix. Have a look at basic primary suffixes as shown on screen. If nature of carbon atom is saturated, it means that there will be a single bond between carbon atoms. Primary suffix will be ane. General name of the compound will be alkane. If nature of carbon atom is unsaturated, it means that there will be a double bond between carbon atoms. Primary suffix will be ene. General name of the compound will be alkene. If nature of carbon atom is unsaturated, it means there will be a triple bond between carbon atoms. Primary suffix will be -ine. General name of the compound will be alkyne. Secondary suffix. The suffix used to represent the nature of principal functional group present in the compound is called a secondary suffix. Let us have a look at some class of organic compounds, functional group, and secondary suffix in them. For alcohol, the functional group is OH. Its secondary suffix is -ol. For aldehyde, its functional group is CHO. Its secondary suffix is -al. For ketones, its functional group is C-double-bond-O. Its secondary suffix is -one. For nitriles, its functional group is C-triple-bond-N. Its secondary suffix is nitrile. For carboxylic acid, its functional group is COOH. Its secondary suffix is oic acid. For ester, functional group is COOR. Its secondary suffix is OH. For amines, its functional group is NH2, NH, N as shown here. Its secondary suffix is amine. For amides, its functional group is CONH2, CONHR, and CONR2. Its secondary suffix is amide. Writing IUPAC name of organic compound. Let us analyze an organic compound shown on screen. Let's select longest carbon chain in it. It has C6 carbon atoms in its longest chain. Word root is hex. Prefix used at position 5 is chloro and prefix used at position 4 is ethyl. Primary suffix used at position 3 is -ene. Secondary suffix used at position 1 is oic acid. Its IUPAC name can be written as 5-chloro, 4-ethyl hex, 3-ene, 1-oic acid. Hence the IUPAC name of the compound is 5-chloro, 4-ethyl, 3-hexanoic acid. Rules to follow nomenclature of open chain hydrocarbons or organic compounds. Identification of the longest chain. Let us have a look at a compound and identify its longest chain. Wrong way to identify the longest chain is shown on screen as 1, 2, 3 and 4. If you look at the structure, we find that there are only 4 carbon atoms in this chain. Let us find another way to find the longest chain. 1, 2, 3, 4, 5 and 6. In this way, we see there are 6 carbon atoms in a chain. In this way, we find that there are more carbon atoms than the previous one. It is the correct way to identify longest chain. Numbering of carbon atoms in the longest chain. Numbering is done in such a way so that the branched carbon atom gets the lowest possible number. For example, let's have a look at the structure of the compound once more. Let's identify longest carbon chain present in it. 1, 2, 3 and 4. It is a correct way to identify longest chain. Now let's start numbering it in a different way. It is a wrong way to identify the longest chain. If a compound contains more than one substituent group, then sum of positions of carbon atoms should be the lowest number. It is also known as lowest sum rule. Let's take an example to clear it. Let's identify longest carbon chain present in it. It has maximum 5 carbon atoms in its longest chain. Let's add positions of functional group attached. Sum of positions 2 plus 4 plus 4 equals 10. This is the wrong way of numbering a compound. Now let us have another way of numbering the compound where sum of positions equals 2 plus 2 plus 4 equals 8. So, lowest sum rule says that the second numbering is correct. Identifying the word root. The numbering of carbon atoms in the longest chain tells the total number of carbon atoms present in it. For example, compound having C6 carbon atoms in its longest chain, it will be named as hex. Naming of alkyl groups. Names of alkyl groups attached as a branch are then prefixed to the name of the parent alkane, and the position of the substituents is indicated by the appropriate numbers. Alphabetical order is preferred in naming of more than one substituent group. If a substituent group is present more than once, use di, tri, etc. The lower number is given to the one coming first in the alphabetical listing. Carbon atom of the branch that attaches to the root alkane is numbered as 1, 2, 3 and 4. In alphabetical order, the prefixes iso and neo are considered to be the part of the fundamental name of alkyl group. The prefixes sec and tert are not considered to be the part of the fundamental name. When only one alkyl group is present, it is named as 2-methylbutane. When similar alkyl group is present at different positions, it is named as 2,2,3-trimethylbutane. When numbering is done according to lowest sum rule. When different alkyl groups are present, it is named as 3-ethyl, 2-methyl, 1-butanol. Here, numbering is done following the order of preference. Functional group gets more preference than the double bond, which in turn gets more preference than triple bond, which gets more preference than side chain. When side chain is complex. Let's take an example of the compound shown here. Let's start numbering longest carbon chain in it. 1, 2, 3, 4, 5, 6, 7, 8, 9 carbon atoms. As we are looking, its longest chain has C9 carbon atoms. Numbering of the longest chain is done according to the lowest sum rule. HC5 is a complex side chain. Its numbering is also shown as 1, 2, 3. It's named as propyl group. Overall, the compound can be named as 5,1,2-dimethyl-propyl 3-methyl-nonene. Naming of substituent groups in cyclic chain is done on the basis of alphabetical order. We are looking at a table showing name of functional group, symbol of that group, prefix and suffix for a particular group. For functional group alkane, symbol is shown in the table. Its relevant suffix is -ane. For functional group alkene, symbol is shown in the table. Its relevant suffix is -ene. For functional group alkyne, symbol is shown in the table. Its relevant suffix is -ine. For functional group halides, symbol is shown in the table. Its relevant prefix is -halo. For functional group alcohol, symbol is shown in the table. Its relevant prefix is hydroxyl and relevant suffix is -ol. For functional group aldehydes, symbol is shown in the table. Its relevant prefix is formyl or oxo and suffix is -al. For functional group ketone, symbol is shown in the table. Its relevant prefix is oxo and relevant suffix is -one. For functional group nitriles, symbol is shown in the table. Its relevant prefix is cyno and relevant suffix is nitrile. Similarly, we can see other functional group, symbol of that group, prefix and suffix for a particular group in the shown table. We are looking at isopropyl group, secondary butyl group, isobutyl group, tertiary butyl group, and neopentyl group. It's time to check our knowledge. Let us try to write the IUPAC name of the compound shown on the screen. And the solution is, let us start numbering the carbon atoms. Its largest chain has C9 carbon atoms, hence its word root is non. Its parent hydrocarbon is nonane. This organic compound has these functional groups: C double bond O, Cl, NO2, CH3, C2H5. As keto group ranks higher than the other groups, its primary suffix is -ane and the secondary suffix is -one. Its IUPAC name is 4-chloro-4-ethyl 3,5,7 trimethyl 6-nitro to nonenone. Give the IUPAC name of the following compound. There are 10 carbon atoms. At positions 5 and 6, 2 ethyl groups are attached. At position 3, a methyl group is attached. A double bond is present between position 4 and 5. So, its IUPAC name is 5,6-diethyl 3-methyl 4-decene.